we are down to the last video for almost every single way to solve for x part 2. And the last part of the notes is solve for the indicated variable. And I think even though this is going to run more than 10 minutes, I'm just going to finish it off from number 8 all the way to 17. And then that way you guys have enough knowledge for you guys to do the rest of the classwork homework. Okay, so let's start off with number 8. These are called literal equations. I have to ask some of my colleagues what these were. Some of these equations are made up. Some of these equations are actual equations, like, area of a circle. So what it is we have some sort of equation and we're solving for a specific variable. So let's start off with number 8. AB plus C is equal to D, and we want to solve for C, meaning we just want to isolate that by itself. Well, one way we can do this is, even though they're multiplied together, it's a positive AB. I'm going to subtract AB on both sides, and then you've already solved for C. C is equal to D minus AB, and that's that for number 8. That's all you can do. Okay, as opposed to number 9. Number 8 and 9 are same equation, but this time it's asking us to solve for B, so we want this by itself. I think one way we can do this is we can subtract C on both sides. AB is equal to D minus C. And then there's a multiplication. I'm going to divide both sides by A, then that way I can isolate B. B is equal to D minus C all over A. Okay. All right, let's do number 10 with a fraction. 7/5 P plus Q is equal to R, and we want to solve for P. So I think I'm just going to subtract Q on both sides first. 7 over 5P. 7/5 P is equal to R minus Q. Okay. We can do one or two ways. You can divide both sides by 7/5, and that's fine. An equivalent is multiplying by its reciprocal. So the reciprocal of 7/5 is going to be 5 over 7. If this was a negative, you also incorporate the negative as well. So you're going to multiply 5/7 on both sides. We're just solving for P. So P is equal to, I think I'm just going to put the 5/7 here. You can distribute this if you want, but we've already solved for P. This is totally fine. All right, number 11, area of a circle, so a real equation. Area is equal to pi r squared, and we want to solve for pi. Although it's not a variable, a pi is 3.1415. It's an irrational number, so let's just solve for that. I think we can just divide both sides by r squared, really. Okay, and then I'm going to put pi on the left side. First, pi is equal to a over r squared. Okay. So I want to put aside, because we have instructions that it says solve for the indicated variable. This is not a variable. Not a variable, but it's an irrational number. Okay, 3.1415. So just solve for pi. Okay, let's do number 12. W, X, Y, Z all multiplied is equal to A, and we want to solve for W. I think we can just do this in one step. We're going to divide everything by X, Y, Z. X, Y, Z. And then W is equal to A over X, Y, Z. And that's it for number 12. Oh, sorry, number 12. That's it for number 12. Divide both sides by X, Y, and Z. Okay. Let's move on to 13. R is equal to numerator 2 times L plus M all over Z, and we want to isolate M. I think here's what I'm probably going to do. I'm going to multiply both sides by Z, because right now this is a divide by Z. Let me just rewrite this equation. So times Z times Z. So we have ZR is equal to 2 times quantity L plus M. From over here, I'm going to divide both sides by 2. I know some people would want to distribute, but I think it might be a little bit easier to just get rid of that 2 already. So divide both sides by 2. RZ or ZR, does not matter, is equal to L plus M. RZ over 2 is equal to L plus M. And then we want to solve for M, so I'm going to subtract both sides by L, and I think we have our answer. M is equal to RZ over 2 minus L. And I write my L's like this, then that way I don't mistake it for the number 1. For my handwriting, anyway. Okay, so that is 13, and I think we have about 4 more to go, and then that's it for this video. Let's do number 14. 14 is also a real equation, surface area of a cylinder, 2 pi r squared plus 2 pi r h, and we're solving for pi. Again, it's not a variable, it's an irrational number, but we're just solving for this irrational number. I see that both of these terms have pi's, and so I think I'm going to factor a pi out. So a is equal to, I'm going to factor a pi out, and then we're left with 2r squared plus 2rh. And we're almost done because now this is a times. I'm just going to divide everything now by this whole factor here, 2r squared plus 2rh. 2r squared plus 2rh. Pi is equal to area over 2r squared plus 2rh. So you know what really this means is if you want to get 3.1415 all the decimals, just take the surface area, whatever that number is of the cylinder, and if you know the radiuses and the heights, plug them in over here, and you should get approximately pi, 3.1415. 15, a times b squared is equal to d, and we got to solve for b. So here's one way you can do this. I'm going to divide both sides by a. B squared is equal to d over a. And then from here to undo the square, you're going to square root both sides. B is equal to square root of d over a. But we can have plus or minus roots if we're going to square both sides. If we're going to square root both sides. Okay. All right, let's do the last two. Number 16. Okay, we got to solve for C. Okay. I'm going to write this twice for notes purposes. So it's a good thing that we've done square root functions, because to undo a square root, what are you going to do on both sides? We're going to square, we're going to raise it to the power of 2 on both sides. So what's going to happen is the square root and the square, they're going to undo each other. So you're just left that with on the left side. And then you have d squared. Okay, from here, let's solve for c. So I think I'm going to subtract both sides by ab. We're almost done. Negative c is equal to d squared minus ab. Okay, and then there is a negative 1. So I'm going to divide everything by negative 1. Okay. C is equal to negative d squared plus ab. Or you can go ab minus d squared. It does not matter. It's the same thing. Okay. All right, last but not least, number 17. Kind of looks like your slope formula a little bit. X equals y minus z all over a minus b. And we want this isolated. So I'm going to write this twice. I want that denominator out of the way. And so what I'm going to do is I'm going to multiply both sides by a minus b. Okay? And that way that fraction is gone. Now I have x times a minus b is equal to y minus z. Okay. I probably would not want to distribute yet. So I think I'm going to get rid of this, not get rid, but just put this over on the other side, this x. Since it's already x times, I'm going to divide both sides by x. A minus b is equal to y minus z over x, and we're almost done. Then your last step is you're going to add b. A is equal to y minus z over x plus b. RA AP Calculus, you guys have enough information to do the rest of the problems by yourself. Okay, thank you.